All right, welcome back. So, I have been experimenting with custom allocators in Odin. And you may know that there is something called a context, which is implicitly passed along to, I think, every function. So there is a context in the main function, which is then kind of like passed here without us knowing. And without us seeing it. And inside that context, there's an allocator, and that allocator is used to perform new memory allocations. So it's possible to replace that with your own implementation if you have some reason to do that. And we kind of do. At least it could be nice in the future to intercept allocations and do something special if you want to be super efficient. The way you create a custom allocator is, first of all, you need this core memory import. Then I've made these aliases here. I just pull out some names. I don't know if there's a better way to do that. You can, inside a function, say using mem, something like that. And then you don't need it, but this way it's usable throughout the file. So the way you make an allocator is basically you have some function that returns an allocator. And the allocator, it has a procedure and it has some data. The procedure is what it does when it's asked to either free or allocate memory. And the data is some kind of arbitrary data that it has, that it might use to perform the allocation, or maybe if you have some kind of logging allocator, it logs all the memory and puts it into the data, something like that. It could also be an arena allocator as a concrete example, where you have an arena. Maybe we should call this arena. So it could be like this. You have an arena, which is an array of bytes. That is where you get new memory from. All right. Now, just what I have made here is just kind of an interceptor. So my allocator data is just a struct that contains another allocator, which is the default allocator. And when I initialize it, I simply take the current context and the allocator from that context and put it into my data. Then the procedure itself, this is just to show that you can intercept it and we can do different things. So the procedure, allocation procedure, looks like this. You get the data of the allocator. That will be this struct, but passed as a pointer, a raw pointer. Then there is an allocator mode, which is either it will allocate, it will free. There's also some other modes, which I haven't covered here. Then there's the size of the new allocation. There is some alignment. There's the pointer to the old memory, which might be nil or not. There's the old size. Then there is the location of the call. Not sure exactly what this is used for. The return value is the new bytes that you have allocated and potentially an allocator error. So the first thing I do is cast the allocator data to the pointer to my struct, and then I get the allocator out. Then I switch on the mode, and I just do some print statements to show that we're actually calling this procedure. And then I call down into some base functions in the memory package. I could also call directly into the allocator itself, which is what I've shown here. But for now, I just think it's fun to keep it this way. Anyway, so if we don't match any of these modes, I've chosen just to exit the program. There's another thing we could do. We could say, actually, I don't know if we have something like this. So if error is not nil, then we could exit. Otherwise, we return bytes and nil. Can we do that? 42. No, it doesn't let us do that. Okay, but we can do this. Remove the parentheses, then say Odin run, and it works. It runs. If we do that just for fun, then it doesn't quite work. So, for example, here we can say that the normal allocator, if it returns an error, it kind of keeps going, just doesn't allocate. So you would have to check for that error, presumably. But we can also say that we just stop the program from running. And let's keep it like that for now. And there's also a specific error for an allocation mode that's not implemented. Here's some more experimentation code. And now you can see how we use it. So let me remove that. And that, don't really need that. So first I make some data. Right now it's just empty. Perhaps we can put nil in here. Let me see. No, it doesn't like that. But we can make it empty, so it's some default value. Then, and this is like the usual pattern that I have gotten from looking at the Odin implementation. So you make the data, you initialize the data, and then you create the allocator using that data. And the final step is then to assign that allocator to the current context, like this. Then when we call make, so here we make a dynamic byte array, size 0 and capacity 0, that will use this allocator. And the proof of that is that we can see that these print statements are being hit. We should see that. Then we defer delete, and delete will call free under the hood. So we should see first an alloc. Then there is the defer delete, which will be called in the end. Then there is an append. And actually, let's do it two ways. So first let's do it like this. Then we should see the allocate here. The append doesn't do anything because there's already, actually let's make the length 0 and the capacity 2. So this shouldn't allocate memory. And then we do this and we print. That doesn't really matter. Let's keep that away from now. So let's do Odin run. Then we see alloc and free here in the output. Okay. Now, just to see where it happens, let's put in this one. Now, I think it should say alloc and then after make and then free. And that's what it does. If we instead make this one 0, so now there's no capacity in this dynamic array. So when we append down here, it will have to increase the capacity, i.e. allocate memory. So that's what happens. It doesn't allocate to begin with. And remember here it allocated to begin with. We can also do this. Then it should also allocate here because the length is already max the capacity. So here we actually see something very interesting. So first we allocate. Then we print this, and then it apparently fails in here. So we're gonna put one debug statement here. Failed to allocate, exiting program. Let's try that and let's see what happens. That's interesting. I don't have a debugger right now. Don't know if there is one. Right, so we do get so it's somehow failing in append. Let's see the return code. I wonder if this will even work. Probably it will still fail, but I wonder what's happening. So evidently, if you try to append to an array that's already full, it just completely fails. That's interesting. That is very interesting. So if I do this, it should also fail. But this should be fine. So I think I know what's happening. And the point is we're only supporting alloc and free. And what's actually happening is we're hitting this one, which is mode not supported, exiting. Let's do something like that. So mode resize not supported and exiting. All right. So I think for now, let's keep it not supported, just because. So you see how it works. The normal allocator, of course, supports all the modes. So it's not a problem normally, but when we use our own allocator, we have to think a little bit more about it. Now, let's do this and this. This chunk, so enums in Odin are not really numbers and you cannot cast them, I think. So let's try this. Let's try format print line cast opcode. Let's make a value first, which is a U8 value 1. Let's try to cast that to an opcode and it will say bad enum value. How about a 0? Okay, so that works. So you can actually cast things. But anyway, there's no need to do that. We can just say that this is an opcode array. And then these appends should probably fail. Everything fails now. So then we say this is an opcode array and we will just push a opcode.opReturn. Okay, so far so good. So we've set up a custom allocator and we have just changed the code a little bit. So now that a chunk of bytecode is actually dynamic array of opcodes. So in the book, he's spending a lot of time on this, which is basically because this part, dynamic, is not implemented in C. You have to implement it yourself, but we get it for free. So That's quite nice. All right, this was just a quick little video on allocators, and see you in the next one.